Welcome all of you. So in this experiment you are going to see about the instrumentation amplifier. So this is the instrumentation amplifier circuit diagram. It consists of three 741 operational amplifier. Op-amp is there. Okay, here the IC number 1 third pin, IC number second IC third pin. You are going to give the function generator as an input. So you will going to set that very minimum of the millivoltage. So and with respect to frequency 1 kilohertz, and then you will going to set about the 200 millivoltage. So I set it a maximum in my function generator. Maximum I have set it around that 500 only. So 500 millivoltage I have applied through that level, and then frequency is 1 kilohertz I have applied. Okay, so initially how to set that one? So this function generator output directly connected to the CRO. So CRO output you will going to connect it. Then you will going to set the frequency using this knob to you can set the frequency 1.1, and then you will go to minimum level, so 200 millivoltage, but I have reduced maximum level is mine is produced on that 500 millivoltage only. I applied 500 millivoltage. Then next one will go come to that one. Once the input is set, okay, set it, then after that we will going to give this connection as per the circuit diagram. Once initially you will going to set, how to set? Function generator connected to the CRO, directly you will going to connect it to the CRO and set the frequency 1 kilohertz, and then voltage VPP is you will going to set. Okay, you will going to set the voltage. Okay, that's all. Okay, minimum voltage you can set, and then see the output is as per the circuit diagram. We are going to make the circuit diagram, and after that you will going to connect the function generator plus terminal and minus terminal, you will going to connect it, and then here you will going to see the CRO output. You will going to see across this 2 points. When you will going to see this 2 point, what is the peak to peak value? So it is a 200 millivoltage, or I in practically I applied for 500 millivoltage. It is increased into the 19 voltage. It is increased into the 19 voltage. It is increased. The same frequency I am not varied. So kept as a constant frequency. I'm what is my output? 19 voltage. See that one. This is a waveform. So waveform is produced. So in that one you have see that one what is the voltage? 19.40 voltage. The frequency is 1.1, okay, 2 kilohertz only. The frequencies I am not touched about anything. So I made the circuit diagram as per the circuit. So as per the circuit diagram is developed. Okay, give the power supply. As per that one we are going to give the power supply. Yes, see that one. Yes. So 500 millivoltage it is increased into that one 19 voltage as an output. Okay. Okay, so you have look what is output of that operational amplifier. This output of the operation amplifier, this is square waveform. Output of the operation amplifier it's a square waveform. I am not vary the frequency. Okay, so next one. Okay, what is the input? So input is a function generator. Through the function generator we are applied as an input. Okay, so frequency, what is applied? The frequency 1 kilohertz. 1.1 kilohertz is a frequency, and then what is the input waveform? So I apply the input waveform is a sine waveform is applied as an input. Sine waveform is applied as an input. So I will go to change. So what is a waveform? Square waveform. Okay. So here is another. Okay. So I will going to change that one. Okay. So what about that output waveform? Square waveform. Sine waveform as an input, then output is a square waveform. Okay. So I will going to give the sine waveform as an input, then output is a square waveform. Okay. So this is about that one. Input is a okay. It is I will going to show you for the input connections. Okay. I will going to show you. Okay. What is output voltage? You will going to just look it. It is a 19.60 voltage. 19.60 voltage. So see the circuit diagram. And then this is a connection of that one. Okay, connection in that breadboard, and the power supply applied. Okay, it's very simple, but see that one very simplest circuit diagram. Only you will going to apply plus VCC minus VCC of that 3 IC. That's why it is showing like more number of the wires. Okay, fine. So I will going to take the testing. So it's a frequency I will going to vary. What about that waveform? So I will going to vary the frequency. See, I have varied the frequency. My VPP is kept as a constant 19.6. Okay, what about the frequency? Okay, the frequency is varying 1.1. Okay, 1.4. Okay, my output voltage is kept as a constant 19.6 only. Okay, I will go to 1 kilohertz. So change into that one. Yes. Press auto. Then see that one output VPP is the same 19.6 only, but the frequency is 4.5 kilohertz. Sorry, wire is disconnected. Okay, see the voltage. So voltage level I am not touched, I am not varied the voltage level, only I varied the frequency. Okay, frequency is 4.5, 4.45 kilohertz. Then voltage is VPP is the same 19.60 voltage only. Further I will going to increase the voltage 6 kilohertz, okay, 7 kilohertz, 8 kilohertz. Then I will going to increase the output voltage is 19.6 voltage only. So it is further I will going to increase. So this is about the frequency adjustment. Okay, so frequency is reduce and the frequency is increase. So like you will going to do. So I will going to see. So press the auto. Yes. So like the waveform is coming on that one. So I want to reduce the frequency 20 kilohertz into that one. So reduce the frequency. Press the auto. What is my frequency? So 5.37 kilohertz. Okay. So we're going to see how to set about the input. Okay, input, how to set it about the input. I will going to tell you. Then we're going to close the session. Okay. So how to we can do? So I will going to take one extra probe. I'm going to take and remove this one. I don't want. So connect this one. Yes, you will going to connect. So you will going to get it on the plus and the minus. Okay, wire. And this function generator. Yes, function generator plus minus, and then CRO plus minus. So CRO plus minus, you will going to make the connections. Yes, it is like a connected function generator plus and connected to that is CRO plus, and the function generator minus, it's connected to that is CRO minus. So set the frequency. Okay, set the frequency. I want to set about 1 kilohertz. One kilohertz frequency is set, and then level. So this is a level. I will going to minimize. It's a maximum. So I will going to reduce and a 0 level. So I want to press that one auto. Then you can see the waveform. And what? Yes, sine waveform. It's a sine waveform we were given. Then what is a VPP? So 430. So 430. Okay, 430 millivoltage is applied, and the frequency is 1.07 kilohertz. Okay, 430 we were applied, and output is a 19 voltage. 19 voltage is an output. Input is a 430, output is a 19 voltage. So this is about the instrumentation amplifier. So instrumentation amplifier, input and output of the waveforms. So input, so this is the input of the waveform, and what is the voltage? VPP is a 432 millivoltage, and the frequency is a 1.1 kilohertz. Thank you.